So welcome everyone. This is part 2 of our OC Mathematical Reasoning paper from the New South Wales Government Department of Education 2023. If you haven't watched part 1 already, please go and watch that now. I've filmed questions 1 to 20 of this paper in that video. So now we're going to film from 21 to 35. Let's start. So 21, Fran has one of each of the shapes below. She can move and rotate. She has an empty 6x6 grid. Fran realizes that she can cover the grid using exactly 4 of these shapes with none of the shapes overlapping. Which shape is not used? Okay, so we only need 4 out of the 5 shapes. And what we're going to do is try and fit them in. So if I use this shape, it's a 1, 2, 3, 4, 5, 6, 6 by 3, okay? So that means that this will be covered here and all 6 will actually be covered like that. So I can shade it in. Now, we want to use the other shapes as well. If I was to put shape B in, it will look kind of like this, okay? If I was to put that in, you can see that there's not enough space to fit C, D, and E. So actually, I'm not going to put B in. Okay, let's try just put the C inside and it'll look like that. Put D in, we can rotate it. Okay, if I rotate this shape, I can stand it up like this. See? And then E will slot in there. The only way of using 4 out of these 5 shapes is to eliminate the big bulky B. So B is the answer. (22) The sum of the 6 number cards below is 25. The diamond and the hexagon represent 2 numbers that are greater than 0, so they're positive. What is the largest possible difference between diamond and the hexagon? So there are 2 different whole numbers and the sum of the 6 numbers must be 25. We can add the current numbers up and see what we get. 8 plus 4 plus 5 plus 2. 8 plus 2 is 10. Let's carry it over. 5 plus 4 is 9. We have a total of 19. Now the sum of the 6 numbers is 25. So we're going to minus off the 19 that we added. We have to borrow 15 minus 9 is 6 and 1 minus 1 is 0. Okay, so we have 6 as the value that we can have between this and this. If I want the largest possible difference, I want one of the numbers to be the smallest we can and the other number to be the biggest we can, and it must add up to 6. Remember, none of the numbers are 0, so the smallest possible number is 1. To add up to 6, the largest possible number must be 5. So when we add that, we get 6. So then what is the difference between 1 and 5? The difference is 4. Option D. (23) Biryani is measuring water in a container. This container has an unusual scale. What is the volume of water that biryani has? What I like to do is see these measurements with the big prong. Okay, so we have 1, we have 2, 3, 4, 5. So 5 of these big ones will take us from 0 to 40. So how much is each of these distances worth? We'll do 40 divided by 5, and you should know from your times tables that's 8. What that means is that each of these little bits are worth 8. Okay, so now we can see the little ones inside. If I draw it out properly, we'll have 1, 2, 3 little lines inside, and that means there's 1, 2, 3, 4 gaps between 0 and 8. And that means that each little gap is worth 2 milliliters. So if you see where our volume is right now, we have 1 big gap, 2 big gaps, 3 big gaps and a little gap. So big gap is 8, so 8 times 3 is 24, and the little gap is 2, so we have 24 plus 2 will give us 26, which is C. All right, question 24. Hayden follows these instructions. Choose a starting number. Add 4 to your number. So we'll choose a starting number. We don't know what it is. We add 4 to the number, and then we times 2 after we figure out the number, and then the answer is 40. What do you get if you add up the digits in a starting number? Okay, so let's find the starting number first. I had to take the whole thing and then times it by 2, and then I got 40. So if we work backwards, we can divide it by 2 and realize that this plus 4 must equal 20. Now something plus 4 is 20. Work backwards. That something must be 20 minus 4, which is 60. Now they ask us to add together the digits. 1 plus 6. Oops, I'm too ahead of myself. 1 plus 6 is 7. And the answer is B. Right, let's zoom in on 25. So, 25. The children in a class are making a new type of money. They decide that 9 squigs are worth 2 zots and 3 zots are worth 5 groggles. How many squigs are 20 groggles worth? I like to write these out in simplified abbreviations. S for squigs, the same as 2 zots. 3 zots, the same as 5G for goggle. We want 20G. Let's go to zots first, okay? So I'm going to write a little line for Z because I don't want to confuse it with a 2. How do I get from 5 to 20? We times 4. So whatever we do to one side, we must do to the other. Times 4, 3 4s are 12. That means that 20 groggles will be worth 12 zots. Now, if I put 12 zots here, how do I get from 2 to 12? We times 6. Whatever we do to one side, we must do to the other. So 9 times 6 is 54 squigs. And that means 54 squigs must be the same as 12 zots. So the answer is C. (26) 20 boxes are going to be packed into bags. Each box has a mass of 400 grams. Each bag can hold a mass of up to 1.5 kilograms. What is the smallest number of bags needed to pack all the boxes? Okay, so we have 20 boxes and each box is 400. Okay, so let's see the total amount of weight that we will need to account for. We get 0, 0, 0. Drop a 0. 2 times 0 is 0. 2 times 0 is 0. 2 times 4 is 8. We add. So we have 8,000 grams. Each bag can hold 1.5 kilograms. 1.5 kilograms in grams is 1,500 grams. So we're going to do 8,000 grams divided by 1,500 grams. We can actually cancel out the 2 zeros on both of them to make it easier for ourselves. 15 into 80. So I know that 15 times 2 is 30, and then times 4 is 60, and then 75. So I'm going to do 5. 5 fives are 25, and then we have 75. And you see how we have a remainder of 5. We can't leave this, even though it's a small remainder, we can't leave this by itself. So we must add on an extra box, which makes a total of 6 boxes, or option C. So I can see here that the answer says it's D, but I believe that it is C. So if you put C, I think that you can mark it correct. Okay, so 27. The column graph shows the number of car tires replaced by two mechanics, Phil and Susie, in one day. The scale is missing from the graph, so we don't see the numbers here. Okay. The picture graph shows the number of tires replaced by Phil. The pictures for Susie are missing. What should be the picture graph for Susie? Okay, so for Phil, let's count how many tires he's fixed. We have 4 from here, the key. We have 4, and we can see that 2 tires is half. So 4 plus 4 is 8 plus 2 is 10. That means that Phil did 10. You can see that Phil's graph occupies 2 portions, and it's 10. So that means that each portion will be worth 5. Now Susie's occupies 1, 2, 3 portions, which is a total of 15, or 5 more than Phil. So to illustrate 15 for Susie, I'll write it here. We're going to use the biggest tire first. So let's try and get as many of the big tires down. We have 4, 8, 12. And now from 12, we need an extra 3. And how do I illustrate 3? Using this one. It's 3/4. Let me draw that better. 3/4 of a tire. So we need 3 full tires and a 3/4 one, which looks like option E. "28. 6 children are going to play in a tennis tournament. Each child will play every other child once. How many matches will there be in total?" So for this one, each child will play the other child once. Okay, so if I have child A, we have B, C, D, E, F. Okay, that's 6 children. A will play 5 children, right? We have 5 children. Now when it's time for B to play, he's not going to play A again because he's already played A. So B will then play B, C, D, E, F. So we have 4 more matches. And do you see a pattern there? C have already played with B, has already played with A, so there was only 3 more people to play with. So we'll continue to add until we get to 1. Now I want to try and make 10s, okay? 5 plus 3 plus 2 is 10. And then 4 plus 1 is 5. So we get 15 matches altogether. 29. Here is a part of a number line. The arrow represents 1 jump. Starting from 9, what value will be reached on the number line after 11 jumps? So in this number line, let's have a look at what is the gap between 8 and 9, and that way we can figure out what each of these jumps are worth. So if I jump 1, 2, 3, 4, then I'll make up the gaps between 8 and 9. What that means is that each jump is worth a quarter. Okay? So from here, we want to have 11 of these jumps. Okay? So that means that we want 11 lots of a quarter, which is the same as 11 over 4. If I make this into a mixed numeral, 4 goes into 11 twice, right? And then we have 8, 9, 10, 11, 3 left. So it'll be 2 and 3/4. Now we start from 9. We're going to subtract 2 and 3/4. Let's subtract the 2 first. 9 minus 2 is 7. We still have to minus the 3/4. When I go back 3/4 from 7, we'll have 6 wholes and a quarter left. So it'll be 6 1/4, which is A. Okay, 30. Here is a bus timetable. Sarah and her friends live in Forster and take the 8:50 bus to Coffs Harbour. They stay in Coffs Harbour until they get a bus home, arriving in Forster at 9:19 that evening. How long do they spend at Coffs Harbour? Okay, so we take an 8:50 a.m. bus from Forster to Coffs Harbour. Okay, so we can see here from Forster, it'll leave at 8:50 and it'll arrive at Coffs Harbour by 1:39. Now, we stay in the Coffs Harbour until they get a bus home, arriving in Forster again at 9:19 in the evening, which means they must have caught this bus, and they had to leave Coffs Harbour at 4:25 to get to Forster by 9:19. So that means that the amount of time they must have stayed is between 1:39 p.m. to 4:25 p.m. So from 1:39 to 2 o'clock, that's 21 minutes, right? And then from 2 o'clock to 4 o'clock, that's another 2 hours. And then from 4 o'clock to 4:25 is another 25 minutes. So we add them all up. 21 plus 25 is 46 minutes. And then we have 2 hours. So altogether, it took 2 hours and 46 minutes. 31. Brian and Yaram are collecting cards. Altogether, they have 250 cards, but Yaram has 18 more than Brian. How many cards does Yaram have? To figure out this one, we can subtract the amount that Yaram has more than Brian first, and then split it equally, and then give Yaram 18 more. So from 250, let's minus 18. We have 232. And then divide that equally among the two boys. Once goes in once, we'll minus, get 12, 6, with no remainders. So that means that Brian will have 116, and Yaram will have 116 plus, how much we minus was 18. 116 plus 18, get 4 carry, total of 134, or option C. (32) In a restaurant, the same amount of veggies need to be chopped every day. Ramesh chops the vegetables on a Thursday. If he starts at 8:45 and works as quickly as he can, he finishes at 9:25. Lucinda does it on a Friday. She starts at 8:25 and she finishes on 9:05. They both chop on Saturday. If they start at 8:35 a.m. and work as quickly as they can, what time will they finish? Okay, so let's see how long it takes both of them to chop the veggies. Ramesh, it'll be from 8:45 to 9:25, which is, let's say, 15 minutes until 9, and then 25 more minutes, take 40 minutes. For Lucinda, she starts at 8:25 and finishes at 9:05. So it'll take her also 40 minutes. So they actually take the same amount of time. And that means that when they both chop on Saturday, if they start at 8:35, then if they did it individually, it'll take 40 minutes. But because they're doing it together, it'll take half the time, which will be 20 minutes. So we do 8:35 plus 20 gives us 8:55, or option A. 33. Cho saves money by putting it in a money box. At the start of Monday, the box is empty. At the end of Monday, we have $12. End of Wednesday, we have $30. End of Friday, we have $80. She puts in the same amount of money on each of Tuesday, Wednesday, and Friday. How much money does she put in on Thursday? Okay. So Monday, Tuesday, Wednesday, Thursday, Friday. We know that Monday we have $0, right? And then on Tuesday, so end of Monday we'll have $12. Okay, so we know that on Monday we added $12. At the end of Wednesday we have $30. And in the Friday we have $80. Okay, so you can see that we've taken some gaps between Tuesday and Wednesday, and then Thursday to Friday, right? Let's see how much we actually added From $12 to $30 is an addition of $18. And from $30 to $80 is an addition of $50. Now, Tuesday, Wednesday, Friday, they added the same amount, which means to get from 12 to 30, we must have added the same amount from Monday to Tuesday, and then the same amount from Tuesday to Wednesday. Okay, and that must have been $9. Okay, and that means the same amount must have been for Friday as well. Okay, she puts in the same amount for Friday, so it'll be $9 as well. Now that means that whatever this value had, so that she put in on Thursday, okay, on Thursday, it will be $9 minus the $50. So 50 minus 9 will give us 41, which is option E. (34) The diagram shows a seven-sided shape. It is cut along 3 dashed lines as shown. This makes 4 pieces, 3 triangles, and 1 other shape. How many sides do the 4 pieces have in total? Okay, so let's count. We have 1, 2, 3, 1, 2, 3, 1, 2, 3. So we have 3 lots of 3 for the triangles, which is 9 sides. Now, for the other shape here, we will count 1, 2, 3, 4, 5, 6, 7, 8. And we add it together and we get 17, which is option E. And the last question. The map shows some of the Aboriginal regions of Eastern Australia. Shu Yi plans a route from Tamworth to Brisbane, which have been shown in bold here. On a route, she only travels north or east. So she can make as many turns as she wants, but always travels north or east. What is the greatest number of different regions she could pass through? Do not include Kamilaroi or Yugara. Okay, so we're not including the one that she's starting with or ending with, okay? So using our compass, this way is north, they said. Never eat soggy Weet-Bix is the acronym that I use to memorize NSW, the positions. She can only move north and east. So let's try draw it, okay? Starting with Tamworth, we can only go east and north. So I'm going to go east first, and then go into this bit here, north, and then go a little bit east to this point here, okay? And then we'll go up. And you can see here, let's go straight. If we go up enough, we'll pass by Bundajalong, and then we'll enter into Nagaraba, okay? And then actually we can go pass into this area here, and then we must make a sharp right turn to end up in Brisbane. So how many did we enter into? Well, we did 1, we did this one, 3, 4. We actually entered the Bundajalong here, so 5, and then 6 we did a little bit of Nagarabal, and then we actually also did 7 Barungaram by entering into here and crossing over like that. So that's a total of 7, not including the ones we started or ended in, and that will make the answer D. Okay, so that's actually it for all of the questions from the second part of this tutorial. I hope you guys got something out of that video. Please go back and re-watch the questions that you got wrong. Try them again and see if you can match up with the solutions. All right, so hope you enjoyed and good luck.